What is the human population density of Earth? This sounds like a question that could be easily answered with one number. What's the surface area of the Earth? It's about 510 million square kilometers. What's the human population of the Earth? As of the making of this video, about 7.84 billion. So, let's just divide the second number by the first to find the population density of the Earth to be about 15.4 people per square kilometer. Now, why does this number feel low? Welcome back to TwoLambdaPlusBlack. I am Heirua. Here's two different numbers you might see for the population density of the United States. 33.4 people per square kilometer and 35.9 people per square kilometer. Actually, if you're American, you'd probably not see these numbers either since they use kilometers, so here you go. Why the two different numbers? The first number uses the most common figure for the area of a country, total area. The second number uses another such figure, the land area. The difference between the two figures is the area of a country covered by inland waters. So which is the better number to use? For most population density purposes, it would be the second figure, the one with land area. Population density is supposed to give a sense of how crowded or packed a place is, and humans just don't live on the water. Let's make this clear by looking at an extreme case. Imagine a hypothetical country that was one gigantic annulus around a lake that covered most of the country, maybe like a ludicrously large atoll. Dividing by the total area instead of the land area will give one the impression that the country is far less crowded than it actually is. Taking this into consideration, why is 15.4 people per square kilometer not the right figure to use for the population density of the Earth? Because that's based on the Earth's full surface area, and 70.8% of the Earth's surface is water. Far more reasonable is to use the land area of the Earth, which is about 148 million square kilometers, giving a population density of 52.6 people per square kilometer. One could actually go a bit further and use the Antarctica excluding land area figure, which is about 135 million square kilometers, giving a population density of 58.1 people per square kilometer. Since it could be fairly argued that Antarctica really isn't land for human livability purposes. Though, to be fair, there are actually humans living in Antarctica now, and unlike Greenland, no one there has gotten COVID yet. If we disqualified Antarctica, however, we may want to disqualify further pieces of land as well, and it's not clear where we should draw that line. I think both these figures, per land including Antarctica and per land excluding Antarctica, are fair figures to call the human population density of Earth. What we could use the 15.4 figure for, though, is to view it as a threshold for evaluating an extremely sparsely populated country. Of the countries of the Earth, several dozens have a population density lower than the land area-based density, as one might expect. But there are 17 countries with a population density below 15.4 people per square kilometer. These 17 countries, Canada, Guyana, Suriname, Bolivia, Iceland, Libya, Mauritania, Chad, the Central African Republic, Gabon, Namibia, Botswana, Russia, Kazakhstan, Turkmenistan, Mongolia, and Australia, have so much uninhabited space that the density of humans within those countries is less than the average human density of Earth's surface even when averaged across the oceans and Antarctica. And we could actually take this idea one step further. Aside from the Earth, there are some other bodies in the solar system with solid or liquid surfaces, like Mercury, Venus, Mars, moons, dwarf planets, and a whole bunch of random rocks. The combined surface area of the terrestrial planets is about 1.19 billion square kilometers. When round planetary moons are added in, this bumps up to 1.61 billion square kilometers, and when dwarf planets and other large trans-Neptunian objects are added in, the total gets to 1.68 billion square kilometers. Looking at the number of smaller solar system objects known, I'd estimate that 1.8 billion square kilometers is a fair upper bound for the total solid and liquid surface area of known objects of the solar system, which computes to a density of 4.3 people per square kilometer. And this quantity exceeds the density of 9 countries on that list. Now, Greenland, not a sovereign country but a territory, has a much smaller population density than even Mongolia, which leads us to ask, what if we even included the gaseous and plasma surfaces of the solar system? Adding in Jupiter, Saturn, Uranus, and Neptune to our surface area total, we get 122 billion square kilometers, for a population density of 0.06 people per square kilometer. Much lower than Mongolia's population density, but indeed higher than Greenland's. Adding in the Sun's surface area, we get 6.21 trillion square kilometers, for a population density of 0.001 people per square kilometer, which is lower than Greenland's. On the other hand, Antarctica's summertime peak human population is about 5,000, so Antarctica's peak human population density is about 0.0003 people per square kilometer. So the human population density of Antarctica is lower than the average human population density across all known surfaces of the solar system. It turns out Antarctica's population density is 5 orders of magnitude less than the Earth's average, while the Sun's surface area is only 4 orders of magnitude higher than the Earth's. Thank you for watching. Leave your thoughts on Antarctica below in the comments. This video was made possible by these lovely patrons. Oh, and look, it's your puzzle of the day. What should replace the question mark here? Leave your guesses in the comments as well. I'm sorry I've been gone for a while, as several things have come up in my life. While I was gone, though, I hope you all remembered to love the night.